Chapter 6 Application of Derivatives Exercise 6.3 or 6.5 in the previous textbook. Question number 21, that is, of all the closed cylindrical cans, right circular, of a given volume of 100 cubic centimeters, find the dimension of the can which has the minimum surface area. So let us consider the radius of the can, circular can will be x, and height of the can, that is the circular cylindrical can, will be y. Now we have given that volume is equal to 100 cubic centimeter, that means V is equal to 100 cubic centimeter. And what is the equation of volume? That is pi r square h. Instead of r we have x and h we have y, so we have pi x square y. Similarly, the surface area of cylindrical can, that is S is equal to 2 pi r square plus 2 pi r h. Instead of r we have x, and instead of height we have y, so 2 pi x square plus 2 pi x y, that is S. So in the question it's given that volume is 100 cubic centimeters. So we have V is equal to pi x square y. Instead of V we are substituting 100. So 100 is equal to pi x square y. From this y can be found, that is 100 by pi x square. So we have surface area S is equal to 2 pi x square plus 2 pi x y. Instead of y we are substituting 100 by pi x square. So we have 2 pi x square plus 2 pi x into 100 by pi x square. Cancelling pi x from numerator and denominator we have the remaining, that is 2 pi x square plus 200 by x. So we have S is equal to 2 pi x square plus 200 by x. So we want to find surface area should be minimum. We want to find the minimum surface area first. So what is ds by dx? That is d by dx of 2 pi x square plus 200 by x. D by dx of 2 pi x square, that is 2 pi into 2x, that is d by dx of x square, plus d by dx of 200 by x, that is minus 200 by x square, or we can write 2 pi into 2x, that is 4 pi x minus 200 by x square. So that is ds by dx. Now what is d square s by dx square? That is d by dx of 4 pi x minus 200 by x square. D by dx of 4 pi x, that is 4 pi only, minus d by dx of 200 by x, that is 400 by x cube, minus 400 by x cube, so it becomes plus 400 by x cube. So we have d square s by dx square is equal to 4 pi plus 400 by x cube. When ds by dx is equal to 0, we can write 4 pi x minus 200 by x square is equal to 0, or from this 4 pi x is equal to 200 by x square, or x cube is equal to, taking x square into the left side, that is x cube is equal to 200 by 4 pi. Cancelling 200 and 4 we have 50. So 50 by pi. So x can be written as cube root of 50 by pi, or 50 by pi whole raised to 1 by 3. So at x is equal to 50 by pi whole raised to 1 by 3, we are going back to the equation of d square x by dx square, that is 4 pi plus 400 by x cube. Substituting instead of x cube, that is 50 by pi whole raised to 1 by 3, we will be getting a positive quantity. That means it is greater than 0. So that means we have the minima here. So S is minima at when x is equal to 50 by pi whole raised to 1 by 3. So what is y? We have y is equal to 100 by pi x square. So instead of x we are substituting 50 by pi whole raised to 1 by 3, that is 100 by pi into 50 by pi whole raised to 1 by 3 into x square, that is 2 by 3, or we have 100 by pi. Cancelling 100 and 50, pi and pi, we have 2 into 50 by pi whole raised to 1 by 3. So that is y. So surface area is minimum at what is x? X is equal to 50 by pi whole raised to 1 by 3, and y, that is equal to 2 into 50 by pi whole raised to 1 by 3, that is 2 into cube root of 50 by pi, or x is equal to cube root of 50 by pi, where x is the radius of the circular can and y is the height of the circular can. So height is equal to 2 into cube root of 50 by pi. Question number 22. A wire of length 28 meter is to be cut into pieces. One of the pieces is to be made into a square and the other into a circle. What should be the length of two pieces so that the combined area of square and circle is the minimum? So we have given the length of the wire, that is 28 meter. Now a piece is cut into the form of a square, let it be x, and the piece cut into the form of a circle, that will be 28 minus x. Now we have the circle here, and that 28 minus x forms a circle with radius r. So we can write the circumference of the circle is equal to, that is 2 pi r, which is equal to length of the wire that is made into the circle, that is 2 pi r is equal to 28 minus x. Now area of the circle is pi r square. In case of the square, we have x is the length made into the square. So x is equal to, if a be the one side of the square, we can write p is equal to a plus a plus a plus a. That means the perimeter of the square, that is x is equal to 4a. Or what is the area of the square, that is a square. So if x is equal to 4a, we can write a is equal to x by 4. Area is equal to x by 4 whole square, that is x square by 16. So now we will be writing the things we have taken down. That is, consider, let x be the length of the wire that is made into the square, and 28 minus x, that is the length of the wire that is made into the form of a circle. In the case of a circle, it is given that the circumference of a circle is 2 pi r, which is equal to 28 minus x, the length of the wire made into the circle. So we can write r is equal to 28 minus x by 2 pi. So what is area of a circle, that is pi r square, or we can write pi into, instead of r, that is 28 minus x by 2 pi whole square. So we can write area of a circle is equal to pi into 28 minus x whole square by 2 pi whole square, that is 4 pi square. Cancelling pi and pi, we have 28 minus x whole square by 4 pi. That is the area of a circle, let it be AC. Now area of a square that we have found, that is x square by 16. That is ASB area of square, that is equal to AX square by 16. Now what is the total area of, that is area of a circle plus area of a square, that is 28 minus x whole square by 4 pi plus x square by 16. Now we will be having, that is the total area, that is 80. Then what is d by dx of 80? That is d by dx of 28 minus x whole square by 4 pi plus x square by 16. That, or d by dx of 28 minus x whole square by 4 pi. 1 by 4 pi is a constant there. So 1 by 4 pi into d by dx of 28 minus x square, that is 2 into 28 minus x into d by dx of minus x, that is minus 1, plus d by dx of x square by 16, that is 1 by 16 into d by dx of x square, that is 2x. Or we can write minus 28 minus x by 2 pi plus x by 8. Or x by 8 minus 28 minus x by 2 pi by rearranging. So that is d 80 by dx. Then what is d square 80 by dx square? That is d by dx of x by 8 minus 28 minus x by 2 pi. Similarly, 1 by 8 is a constant. So 1 by 8 into x, that is d by dx of x, that is 1 minus 1 by 2 pi into d by dx of 28 minus x, that is minus 1. Or we can have d square a by dx square is equal to 1 by 8 plus 1 by 2 pi. If we solve the above problem, we will be always getting a positive quantity that is greater than 0. So we will be having a minima here. So when dAt by dx is equal to 0, we can write x by 8 minus 28 minus x by 2 pi is equal to 0. Now cross multiplying, we have 2 pi x minus 8 into 28 minus x is equal to 0 by 8 into 2 pi is equal to 0. Taking 8 into 2 pi into the left side, that becomes 0. So we have 2 pi x minus 8 into 28 minus x is equal to 0, or 2 is taken common. So pi x minus 4 into 28 minus x is equal to 0, or 2 is cancelled. So pi x minus 4 into 28 minus x is equal to 0. 4 is taken into the bracket, so we have pi x minus 112 plus 4x is equal to 0. X is taken common from pi x and 4x, so x into pi plus 4 is equal to 112 is taken into the left side, that is equal to 112, or x is equal to 112 by pi plus 4. Now we have d square by dx square, which is greater than 0. So we have minima here. Now what is x? That is 112 by pi plus 4. What is x actually? X is said to be the length of wire into which a square is made. Now 28 minus x is the length of the wire into which the circle is made. So what is 28 minus x? That instead of x we have 112 by pi plus 4, that is 28 minus 112 by pi plus 4. By cross multiplying, we have 28 into pi plus 4 minus 112 by pi plus 4. Opening the bracket, we have 28 pi plus 28 into 4, that is plus 112 minus 112 divided by pi plus 4. Cancelling 112 plus 112 and minus 112, we have 28 pi by pi plus 4. Question number 23. Prove that the volume of the largest cone that can be inscribed in a sphere of radius r is 8 by 27 of the volume of sphere. So I have given a sphere in green color and a cone is inscribed in the sphere. Let capital letter R be the radius of the sphere. Now we will be having a cone with a radius of its base, that is smaller r. So now what is the height of the cone? Let it be marked as h. So h be the height of the cone. So we have v be the volume of the cone. Now from the center of the sphere to the side of its cone, let it be r, the radius, and the distance from the cone, the remaining distance, that is h minus r. So we will be marking a triangle here, that is triangle AOB. It is a right angled triangle with an angle 90 degree in among one of the angle, applying the Pythagoras theorem in that triangle as I have shown. So that is AB square is equal to AO square plus OB square. So what is AB? That is bigger r, AO square, that is smaller r, and OB is equal to h minus r. So we have r square is equal to smaller r square plus h minus bigger r whole square. So we have capital R square is equal to small letter r square plus h square minus 2hr plus capital letter r square. Capital letter r square is cancelled. So we have the remaining, that is smaller r square minus r square is equal to the remaining, that is h square minus 2h capital letter r, or we can write smaller r square is equal to 2h capital letter r minus h square. So we have the volume of the cone, that is 1 by 3 pi r square h, or 1 by 3 pi into what is r square, that is 2hr minus h square into h, taking h into the bracket. So we have 1 by 3 pi into 2h square r minus h cube. Or now differentiating v with respect to h, we have dv by dh, that is d by dh of 1 by 3 pi to h square r minus h cube. 1 by 3 pi is constant, so d by dh of 2h square r, that is 2r into h square, that is 2h minus h cube, that is d by dh, that is 3h square, or dv by dh is equal to 1 by 3 pi 2 into 2 4 rh minus 3h square. Now we will be finding what is d square v by dh square, that is d by dh of 1 by 3 pi 4 rh minus 3h square. So here also 1 by 3 pi is constant. So taking that outside, so 1 by 3 pi into d by dh of 4rh, that is 4r is constant, 4r minus 3h square, that is 3 into d by dh of 2h square, that is 2h. So we can write d square v by dh square is equal to pi by 3 into 4r minus 6h. When dv by dh is equal to 0, we can write 1 by 3 pi into 4rh minus 3h square is equal to 0, or 4rh minus 3h square is equal to 0, or h is taken outside, so h into 4r minus 3h is equal to 0. So h is equal to 0, or 4r minus 3h is equal to 0. So from this h is equal to 4r by 3. So we have got two values for h, that is 0 and 4r by 3. Now h is equal to 0 is not taken because it's not possible value here. So we will be taking, we need a value for h, right? So we will be having h is equal to 4r by 3. So what is d square v by dh square? That is 1 by 3 pi into 4r minus 6h. So instead of h, we are applying the value 4r by 3. That is 1 by 3 pi into 4r minus 6 into 4r by 3, cancelling 6 and 3. We have 1 by 3 pi 4r minus 2 into 4, that is 8r. So when we solve the above problem, we will be having a negative quantity which is less than 0. So we can write we have maximum at h is equal to 4r by 3. Now we are going back to the volume, that is 1 by 3 pi into 2h square r minus h cube. That is the volume of the cone inscribed in the sphere. So instead of h we are applying 4r by 3. So we have 1 by 3 pi into 2 into r into 4r by 3 whole square minus h cube, that is 4r by 3 whole cube. Or we can write v is equal to 1 by 3 pi into 2r into 4r by 3 whole square, that is 16r square by 9 minus 4r by 3 whole cube, that is 64r cube by 27. Or we can write 1 by 3 pi into 16 into 2, that is 32r cube by 9 minus 64r cube by 27. Now making common denominator 27, we have multiplying 3 with the 32r cube by 9, we have 1 by 3 pi into 96r cube minus 64r cube by 27, or 1 by 3 pi into 96 minus 64, that is 32r cube by 27. Now taking 1 by 3 pi into the bracket, so we have 32 pi r cube divided by 3 into 27. 32 can be written as 4 into 8. So 4 into 8 pi r cube divided by 3 into 27. 8 and 27 is taken outside. So the 8 by 27 into the remaining, that is 4 by 3 pi r cube. So what is 4 by 3 pi r is the capital letter r. So 4 by 3 pi r cube, that is the volume of the sphere. So we can write volume of the cone. V is equal to 8 by 27 into volume of the sphere, or volume of the largest cone is equal to 8 by 27 of the volume of the sphere. Question number 24. Show that the right circular cone of least curved surface area and given volume has an altitude equal to root 2 times the radius of the base. So I have given a cone here. So it's having a height h with radius at its base, that is r, and a latent height l. So let r be the radius of the cone, h be the height of the cone, l be the latent height of the cone. Now v will be the volume of the cone and s will be the curved surface area of the cone. Now first, what is volume of the cone? That is, we have the equation for volume of the cone, that is 1 by 3 pi r square h. So from this, h can be find it out, that is h is equal to 3v by pi r square. So we have given the curved surface area of the cone, that is, what is the equation for curved surface area? That is s is equal to pi rl, or pi r into l. So what is l? In order to find l, we have h and r, we are considering the right angle triangle here. So since L is a hypotenuse, we can write L square is equal to h square plus r square, or L is equal to root of h square plus r square. Substituting that, we have s is equal to pi r into root of h square plus r square, or s square is equal to pi square r square into root and square is cancelled, so h square plus r square. So we have s square, equation for s square. Now instead of h, we are first opening the bracket. So s square is equal to pi square r square h square plus pi square r square into r square, that is pi square r raised to 4. Now instead of h, we are substituting the value of h, that is 3v by pi r square. So we have pi square r raised to 4 plus pi square r square instead of h square, that is 3v by pi r square whole square. Or we can write pi square r raised to 4 plus pi square r square into 3v by pi r square, that is 9v square by pi square r raised to 4. So we have pi. Cancelling the pi square r square from numerator and denominator in the second term. So we have s square is equal to pi square r raised to 4 plus 9v square by r square. Now what is d by dr of s square? That is d by dr of pi square r raised to 4 plus 9v square by r square. D by dr of pi square r raised to 4, that is pi square into d by dr of r raised to 4, that is 4r cube, plus d by dr of 9v square by r square, that is 9v square into d by dr of r raised to minus 2, that is minus 2r raised to minus 3, that is minus 2 by r cube. So we have pi square 4r cube minus 9 into 2, that is minus 18v square by r cube. That d by dr of s square is equal to 4r cube pi square minus 18v square by r cube. When d by dr of s square is equal to 0, we can write 4 pi square r cube minus 18v square by r cube is equal to 0, or 4 pi square r cube is equal to 18v square by r cube. R cube is taken into the left side, so we have 4 pi square r raised to 6 is equal to 18v square, or from this r raised to 6 is equal to 18v square by 4 pi square. 4 and 18 is cancelled, so we have 9 by 2 v square by pi square, that is r raised to 6, or r is equal to 9 by 2 v square by pi square whole raised to 1 by 6. Now moving into the second derivative, that is d square s square by r dr square, that is d by dr of d by dr of s square, that is d by dr of 4 pi square r cube minus 18 v square by r cube. So we have d by dr of 4 pi square r cube, that is 4 pi square into r cube, that is 3 r square minus 18 v square into d by dr of r cube r raised to minus 3, that is minus 3 r raised to 4, or we have 4 into 3, that is 12 pi square r square plus 54. 8 into 3 is 54 minus, so plus 54 v square by r raised to 4. So if we are applying a value of r into this equation, and when we solve that, we will be getting a positive quantity, that is clear. So if we are getting a positive quantity, we will be having minima when r is equal to 9v square by 2 pi square whole raised to 1 by 6. Now we are going back to what is h, that is at initial h is equal to 3v by pi r square. So we dividing both left hand side and right hand side by r. We have h by r is equal to 3v square by pi r square into r, that is pi r cube. So that is h by r. So instead of r, we are having 9v square by 2 pi square whole raised to 1 by 6, substituting that. 3v by pi into 9v square by 2 pi square whole raised to 3 by 6, or that is h by r. So h by r is equal to 3v by pi into 9v square by 2 pi square whole raised to 1 by 6 whole cube, or 3v by pi 1 by 6 into 3, that is 1 by 2. 6 and 3 cancel. So we have 3v by pi into 9v square by 2 pi square whole raised to 1 by 2, or we can write 3v by pi into root of 9v square by root of 2 pi square. We are taking 1 by 2 is root, so we can write 3v by pi into 3v by root 2 pi. Pi square v square 9 is taken outside. 9 is the root of 3. So we have h by r is equal to, by cancelling all the terms, we have the remaining, that is only root 2. So we can write h is equal to root 2 into r. So from this we can write curved surface area of a cone is minimum at its altitude. Altitude means h is equal to root 2 of the radius at its base. So in the question, it's given that a cone with least curved surface area is having the and given volume has an altitude which is equal to the root 2 times the radius of the base. That is the question. So hence we have proved. 25th question. Show that the semi-vertical angle of the cone of maximum volume and given slant height is tan inverse root 2. So we have seen a cone here. Let h be the height of the cone. Now r be the radius of the cone, base radius. Now L be the slant height of the cone. And here we will be having an alpha, an angle alpha, that means the semi-vertical angle that is inscribed in between h and L. We have a right angle triangle. So applying the Pythagoras theorem for L, that is L square is equal to, that is the hypotenuse L square is equal to h square plus r square. Or from this, r square is equal to, that means the base radius, r square is equal to L square minus h square. So what is the volume of the cone? That is 1 by 3 pi r square h, that is V. So instead of r, we are applying L square minus h square. So 1 by 3 pi into L square minus h square into h. Now opening the bracket, we have 1 by 3 pi L square into h minus pi 1 by 3 pi into h square into h, that is 1 by 3 pi h cube. Now differentiating volume with respect to h, we have dv by dh, that is 1 by 3 pi d by dh of 1 by 3 pi L square h minus 1 by 3 pi h cube. Now d by dh of 1 by 3 pi L square h, that is 1 by 3 pi L square minus d by dh of 1 by 3 pi h cube, that is 1 by 3 pi into h cube, that is 3h square. Or we have 1 by 3 pi L square minus 3 cancel, so minus pi h square. So that is dv by dh, or can be written as v dash. Now when dv by dh is equal to 0, we have 1 by 3 pi L square minus pi h square is equal to 0, or 1 by 3 pi L square is equal to pi h square. From this, h square is equal to 1 by 3 L square. Pi cancel. So h is equal to root of L square by 3, or L by root 3. So we have got h, that is L by root 3. Now what is d square v by dh square? That is d by dh of 1 by 3 pi L square minus pi h square. So d by dh of 1 by 3 pi L square, that is 0. There is no h term, minus d by dh of pi h square, that is pi minus pi into 2h. So that is d square v by dh square is equal to minus 2 pi h. At h is equal to L by root 3, we have d square v by dh square, that is equal to minus 2 pi into L by root 3, or that is a minus, so negative quantity. So we have v is maximum when h is equal to L by root 3. From the question it says the semi-vertical angle of the cone is maximum in volume and given slant height is tan inverse root 2. This is what we want to show that. So we have the equation for L square, that is L square is equal to R square plus H square. Now instead of L we have H is equal to L by root 3. So L is equal to H by root 3. Substituting that we have L square, that is H by root 3 whole square is equal to R square plus H square. Or R square is equal to H by root 3 whole square minus H square, or H square root 3 whole square, that is 3 itself. So H square minus 3H square. So we have 2H square. So R square is equal to 2H square. From this we R square by H square is equal to 2. So we have R by H is equal to root 2. So we have got what is R by H. Now so from the question we have there is a semi-vertical angle alpha. So what is tan of alpha? We are finding that here. So tan of angle alpha, where alpha is a semi-vertical angle which is equal to the opposite side by the adjacent side. So according to the angle alpha, what is the opposite side? That is R, and the adjacent side is H. So we can write R by H. So tan alpha is equal to R by H. From this, what is alpha? Alpha is equal to tan inverse of R by H. What is R by H? That is root 2. So tan alpha is equal to tan inverse root 2. So we have hence proved that from the question, that is the semi-vertical angle alpha when the volume is maximum is tan inverse root 2.